Hello, guys and gals. I hope you all had a wonderful weekend. I am a little delayed on getting this video posted, but here we are anyway. So we are solving systems of equations. So I am going to share my screen with you. Let's see. Make sure you are doing these along with me, okay? All right, so the way we're going to solve these few systems of equations are by substitution. So the first one here, it already tells us what y equals in the second equation. So we're just going to take this quantity of 9 and we're going to substitute 9 in for y in that first equation. So I'm going to write down 2x plus, it says 3 times y. Well, this tells us that y is 9. So instead of writing 3 times y, I'm going to write 3 times 9. And then I'm going to write down the rest of the equation equals 19. So 2x plus 3 times 9 is 27 equals 19. And now I'm going to solve for x by subtracting 27 from both sides. So I have 2x is equal to 19 minus 27 would be what, -8? And then to solve for x, I would do the opposite of times 2, which is divided by 2. So it says that x is equal to -4. Well, the thing about systems of equations is that you have to figure out what x and y both are. So you always want to write your answer in ordered pair, and ordered pairs are always written in x comma y form. So our x is -4, and on this one, it already told us the value of y. You don't see that very often in systems, but on this one, they started us off a little easy. So the solution to this system of equations is -4, 9, which means basically, if I took both of these equations and I graphed them, they would intersect at this coordinate on a coordinate plane, okay? Another way I know this answer is true is if I plug in -4 for x and y for 9 for y in the first equation, I'm going to get a true statement, okay? In other words, 2 times x is -4, plus 3 times y, and we said y is 9, equals 19. Let's just double check, see if this is true. Well, 2 times -4 is -8 plus 27, and does -8 plus 27 equal 19? Yes, that is exactly right. 19 is equal to 19. So we know our answer is correct. Okay, so that's our first one. Let's move on. All right, now this one says that y is equal to the quantity 3x minus 5. And the second one says y is equal to the quantity -3x plus 1. So let me give you a little math problem to think about. Let's say does 2 plus 3 equal 5 and 6 minus 1 equals 5. Well, since both of these expressions equal 5, then it would make sense that we knew that 2 plus 3 is equal to 6 minus 1, right? And that's true. Now, we set them equal to each other, but because they both equal 5, but did you notice what happened? The 5 disappeared in this statement right here, but they're both equal to 5. So that's kind of what we're thinking about the second one. If this is equal to y and this is equal to y, that means that 3x minus 5 is equal to -3x plus 1. So we are still substituting because we're basically replacing this y right here with this expression, because that's what this tells us. Y is equal to this. So we simply substituted this expression for y, or I could say it the opposite. We substituted this expression for that y. Either way. So we want to get our x's together. So we're going to move this smaller x. So the opposite of negative 3x is plus 3x. So we're adding 3x to both sides first. So this goes away. So 3x plus 3x is 6x minus 5. Over here we have left a 1, right? We want to solve for x, so get rid of minus 5. It would be plus 5, plus 5. So 6x is equal to 6. And then to solve for x, I'm dividing both sides by 6, and I get x equals 1. Well, I'm not finished yet because now I have to solve for y. Because what I told you at the beginning, all of your answers has to be a coordinate, right? So I've solved for x. I know that x is equal to 1. Now I need to solve for y. Well, I have two choices. I could either plug in 1 for x right here or 1 for x in the second one. It doesn't matter. It doesn't matter what you choose. So let's just use the first one. 3 times x, and x is 1. So 3 times 1 minus 5. Well, 3 minus 5 is negative 2. So that's my solution. And just to double check it, I'm gonna plug in or substitute my answer into the second equation to check it. So negative 3 times x, and x is 1, plus 1 equals y. Well, y is negative 2. So let's double check, make sure this is right. Negative 3 times 1 is negative 3, and negative 3 plus 1 is in fact negative 2. So I know for sure my answer is correct. And this is it. This is my solution. Once again, if I graphed these two equations on a coordinate plane, they would intersect at this point, 1, negative 2. That's the only place they'll ever intersect. Whatever the solution is the point of intersection. All right, here we go. There's another one. We're still solving by substituting. So this one's already solved for x for us. So when you're substituting, you want at least one of your equations to either say x is equal to or y is equal to. That's what we're looking for. So I'm going to plug in this value for x in the first equation. So x is, this says x is 3y. So I'm substituting 3y for x plus 5y equals 22. So 2 times 3y is 6y plus 5y is 22. So 6y plus 5y is 11y. And then to solve for y, I'm going to divide both sides by 11, and y is equal to 2. Am I finished yet? Do I know what x is yet? I do not. I don't know what x is, but I know y is equal to 2. So I could either plug in 2 into the first equation for x and solve for y, or look how simple the second one looks. It says that x is equal to 3 times y. Well, I know that y is 2, so 3 times 2 is 6. And just to triple check my answer, I'm going to plug in my solution into the first equation and make sure I get a true statement. So 2 times x, well, 2 times 6 plus 5 times y, so 5 times 2 equals 22. Let's see if it's true. There's 12 plus 10 equals 22, and I know that's a true statement, so I feel confident that our answer is exactly right. All right, let's try another one. Now, remember what I said, if you're going to solve by substitution, you want one of your equations to either say x is equal to or y is equal to. Well, neither one of these say that. So that means I have to solve one of the equations for x or y. So I'm going to pick the first equation. It doesn't matter if I pick the first or second one. And I'm going to solve it for x because x is over here with a coefficient of 1. So all I have to do is move 3y to the other side. So I'm starting off with this equation. If I move that 3y to the other side, it means I have to subtract it. So x is equal to, so there's my x is equal to or y is equal to this expression, which is y equals, I'm sorry, 11 minus 3y. So I'm going to take this quantity and I'm going to substitute in for x in my second equation. If I use 1 to solve for x, I have to plug it into the other equation. So I'm going to use the second equation. X is equal to, so I'm substituting x for 11 minus 3y. There's my x, plus 4y equals 14. So now I'm going to combine like terms. Negative 3y plus 4y, negative 3 plus 4 is positive 1. So positive 1x is plus y. I'm saying x, but I'm looking at a y. Negative 3y plus 4y is positive 1y. And 1y is just y. So now to solve for y, I'm going to subtract 11 from both sides. So y is equal to 3. I'm not done yet because I don't know what x equals yet. I do know that y is 3. So now to figure out what x is, I can go back to my two original equations, pick one of them, substitute 3 for y, and figure out what x is. Okay, so let's do the first one again. So my x is, I still don't know, plus 3 times 3 equals 11. X plus 9 equals 11. And then I'm going to subtract 9 from both sides. So I know that x is equal to 2. There is my answer. What does that solution mean? It means if I graph these two original equations on a coordinate plane, they would intersect in one place, and that place would be on 2, 3. All right, just to triple check my answer, I'm going to pull down that second, oh my goodness. I'm going to pull down that second equation. I'm going to plug in my answers just to be 100% sure that I'm right. So I'm going to substitute 2 for x. So 2 plus 4 times y, which is 3, is equal to 14. Is that true? Does 2 plus 12 equal 14? Yep, it sure does, which makes me 100% sure my answer is right. All right, now let's look at this one. Neither of these equations is solved for x or y, but I can solve it for x or y. I'm always going to pick the most simple looking equation to deal with, which to me is the first one, because I have coefficients of 1 and 1. So I can either solve for x or y. It does not matter. So I'm going to write x plus y is equal to 5. So I'm just going to solve for y by removing x or moving it over to the other side, which means I have to subtract it from both sides. So y is equal to 5 minus x. So now I'm going to take this quantity, I'm going to substitute it in for y in the second equation, as it says y is this. So I'm going to bring down negative 2x plus the quantity for y, which is 5 minus x equals 2. So I'm going to combine like terms. Negative 2x combined with negative 1x. Negative 2 minus 1 is negative 3 plus 5. Yes.
I'm getting pulled to do the free lunch stuff, so I'm not sure how available I'll be. It's today and tomorrow, and I'll
Okay.
2 days next week too.
Okay, thank you for telling me. I'll cover it. Thank you. All right, so negative 2x minus 1x is negative 3x plus 5 equals 2. I'm going to solve for x. I'm going to subtract 5 from both sides. So I have negative 3x is equal to negative 3. And then finally, the opposite of times 3, I'm going to divide everything by negative 3. So x is equal to negative 3 divided by negative 3 is positive 1. So half my answer is 1. And now I'm going to solve for y. So I'm going to use that first equation again. I'm going to pull it over here. X is 1. 1 plus y equals 5. I'm going to move the 1 over, and y is equal to 4. So my solution is 1, 4, which is where these two equations would intersect on a graph. If I graphed both of them, I'm just going to do a real quick check with my answers. Negative 2 times 1 is negative 2. -2 plus 4, -2 plus 4 equals 2, and that's what this says, so I know my answer is correct. Oh, I did it again, you guys. All right, one more on this slide. Now this one is already in the form y equals an expression, okay? I'm always looking for either y equals or x equals something. So one of those variables by themselves, and this one's already in that form. So this one's easy to substitute. I'm just gonna take this whole quantity x plus 1 and I'm substituting it in for y. So in my second equation, x plus y, and y is x plus 1, is equal to 7. I'm going to add my like terms together. So 2x plus 1 equals 7. I'm going to solve for x by subtracting 1. So I have 2x equals 6. And then the opposite of times 2 is divided by 2. And I get 3. So x is 3. I have half of my answer. And now I know that if x is 3, what does y equal? Well, 3 plus 1 is 4. And that's my solution. I could plug it in down here real quick and find out that sure enough, my answer looks great. All right, we've got 6 problems. We just practiced 6 problems. I hope you practice them with me. You need to. You can't learn math by watching me do it. You got to do it with me. Oops. All right, now all of the ones on the first slide had one solution, which means if we graphed these lines on a coordinate plane, they would intersect in exactly one place. But it doesn't always happen that way, guys. Sometimes they won't ever intersect, and sometimes they basically overlap each other. They're basically the same line on top of each other. So what happens when we get a solution like that? Well, let's see. Well, if we're using substitution, let's go ahead and take that second equation and solve it for y, because all I have to do is move one number. I have to move 4, so I'm going to add 4 to both sides. So the second equation is going to say y is equal to 3x plus 4. So I'm going to substitute this quantity for y in my first equation. So I'm going to bring down -12x plus 4 times 3x plus 4 equals 8. I have to use the distributive property. 4 times 3x is 12x. 4 times 4 is 16. Whoops, where did that 1 come from? I didn't mean to write that. All right. And so what happens here? What's -12 plus 12? Well, -12 plus 12 is 0. So I basically end up with 16 is equal to 8. Well, is that true? No, that's not true. Which means that this, actually, I think I put the headings backwards, you guys. That means if it's not true, that means there are no solutions. If it's not true, that means there's no solutions. I need to fix yours before I send it to you. So yours is probably going to look different than mine. So the first one shows us that there is no solutions because this is not true. Not true means no solutions. Just looking at it, make sure I did it right. Yeah, I think I did it right. I think I had my headings were wrong. All right, let's look at the next one. So once again, we're using substitution. So I'm going to find the most simple looking problem, which to me looks, the first one looks a little more simple than the second one. So I'm going to solve for y because I got to move the 3 on the other side. So -y plus 3 is equal to 2x. So I'm going to get rid of the 3 by subtracting 3. 2x minus 3, and then it's not y equals, it's -y. So I have to divide every single term by -1. So a negative divided by negative is positive. Positive 2 divided by -1 is -2, and -3 divided by -1 is +3. So I have solved for y. I'm going to plug this expression in for y in the second equation. So 3 times -2x plus 3 plus 6x equals 9. So I'm going to use my my distributive property. So 3 times negative 2x is negative 6x. 3 times 3 is 9 plus 6x equals 9. When I get those x's together, oh my goodness. Now this one is true. I've messed up my labeling. I guess I just need to take my labeling off. Those cancel each other and we end up with 9 equals 9. Well, is that true? Yes, that is true. So if you end up with a true statement and no variables, the variables they canceled each other, right? If you end up with a true statement, no variables, that means there's an infinite number of solutions, infinitely many solutions. Okay, infinitely many solutions on that one. All right, let's see what else we got here. Now this one's already solved for x. This one's already, no, it isn't solved for y. I need to pay attention to what I'm saying today. All right, so this one, since it's already solved for y for us, we're going to plug this into the second equation for y. So we're going to write negative 2x plus y. Well, what is y? Y is 2x plus 3 is equal to 1. So negative 2x plus 2x is 0, and we end up with 3 is equal to 1. Is that true? No, that's not true. So since it's not true, there's no solutions. Oh, and by the way, do you know what no solutions means? It means you have 2 lines on a coordinate plane that will never intersect. What does that mean? 2 lines that never intersect. You learned that word in like 2nd grade. It means they're parallel lines, right? So basically parallel lines have the same slope. So the first one's in y equals form. So let me just show you on this one. If I solve this for y and move that negative 2x to the other side, negative 2x, the opposite of negative 2x is positive 2x plus 1. So this is our second equation. Our first equation was 2x plus 3. Do you notice they have the same slope? Well, when you have 2 lines that have the same slope, that means they'll never intersect. They are parallel. There's different ways of solving these. All right, and finally, this last one, I'm going to solve for y. All I have to do is move that negative 2x to the other side. So I'm going to do y is equal to positive 2x plus 3. And now I'm going to substitute all of this in for y right there. So I'm going to write negative 4x plus 2 times 2x plus 3 equals 6. So negative 4x is equal to, or excuse me, plus 2 times 2x is 4x, 2 times 3 is 6. Well, these cancel. Negative 4x plus 4x is 0, and 6 is equal to 6. Is that true? That is true, yes. So if you come up, so these two went together, and those two went together. Oh my goodness, I messed this all up, you guys. But you're showing your work on your paper, and you're writing the answers, so ignore my little headings here. I'm just going to get rid of these headings when I do before I send this to you. So if you end up with a true statement and your variables are gone, that means you have infinitely many solutions. Basically, it's the same line. The same lines will line up on top of each other. And let me just see, those of you that find patterns very quickly, let me just show you. If you look at 2 equations and you think, oh, those look really similar, what if all I had to do on that first equation is multiply everything by 2, and what would happen? These two are going to equal each other exactly. 2 times negative 2 is negative 4, 2 times y is 2y, and 2 times 3 is 6. So basically, if you can multiply one equation, the whole thing by one number, and it turns into the second equation, this is infinitely many solutions. Basically, it's the same, it's 2 lines, the same line laying on top of each other. That's what it means. And even though these look a little different, if I move my 2x over here, move my 3 over here, and then I multiplied that whole first equation by 3, it would turn into that second equation, which helps me know that sure enough, they would be the same line laying on top of each other. All right, let's look at these three. The question is, how many solutions do each of these systems of equations have? The first one, since they intersect, they have one solution. When you have only one solution, you have to identify the solution, and the solution is that ordered pair right there. So how do I write this ordered pair? If I start at the origin, don't go right or left. That means my first number is 0, and then I go up 2. So the first answer is one solution, and that solution is 0, 2. Okay? The second one, how many solutions? Well, the answer is 0 solutions or no solutions. Why? It says to explain. The explanation is they are parallel lines, and will never intersect. If they never intersect, that means they don't have a solution, right? And then the last one is the picture of a red line, and then on top of it is an orange line. Well, two equations that lie on top of each other means that there's an infinite number of solutions, or infinitely many solutions, because every single point on each line they have in common. So there's no limit to how many solutions are part of that solution set. I hope that makes sense, you guys. And then this is the last question on this video for you. This is a question I got off your quiz. It says, consider this system of equations. Which description best describes the solution to the systems of equations? Well, first of all, I want to show you two different ways. The first way I'm going to show you is I'm actually going to graph this. So remember, graphing, we start with our y-intercept, +6, and then normally we'd go up 5, right 1. Well, we don't have enough space to go up 5, right 1, so we're going to do the opposite. We're going to go down 5, left 1. 1, 2, 3, 4, 5, left 1. Do it again. 1, 2, 3, 4, 5, left 1. So you guys know I cannot draw a straight line, but let's give it our best shot. Oh my goodness. Pressure, you guys, pressure. All right, let's find the second one. Well, the second one, I'm going to start way down here at -7. And then my slope is -1/1. So that means normally I would go down 1, right 1 this way, but I don't have space. So I'm going to go do the opposite. I'm going to go up 1, left 1, up 1, left 1, up 1, left 1. So they do intersect. Now, they don't intersect at a very pretty whole number. They intersect out here in the middle of this box. Well, it's actually not asking us for the solution. It's just asking us which of these things are true. The other way I could solve this, so I'm still not looking at our choices yet. I want you guys to be able to identify these. You know, if you understand what it's really asking you, then you'll be able to pick out the best answer. Since both of these are equal to y, just like my first equation, I had two expressions that equals to 5. So what I did was I set those expressions equal to each other. Well, same thing here. This is equal to y and this is equal to y. So I'm going to set them equal to each other. All right, I'm going to get those x's together. I'm going to add x to both sides, add 1x to both sides. So 5x plus 1x is 6x plus 6 is equal to -7. I'm going to subtract 6 from both sides. 6x is equal to -13. And then when I divide both sides by 6, I get negative, what is it? About 2 1/6. Well, that makes sense because if you go left 2 and just a little bit, and then I go down, that's where I'm finding this intersection, isn't it? So as long as you can solve for x or y, you know there's at least one solution. Then I could plug in this and figure out what y is, but that's not the point. Let's see what these choices say. It says, so first of all, we know there's one solution because they do intersect. So it says lines this and this intersect the x-axis. So is that why there's one solution? Because they both intersect the x-axis? Well, think about this. Even parallel lines would both intersect the x-axis. They could. That doesn't mean there's any solution. So choice A doesn't make any sense. No. Well, the second one is very similar. Lines, the first and second line intersect the y-axis. Well, they both do. This intersects the y-axis and this intersects the y-axis. But that doesn't mean the reason they have one solution is because they intersect the y-axis. So this one doesn't have any bearing on our answer. This line intersects the origin. Well, yeah, I guess it does intersect. No, it doesn't intersect the origin. Neither of the lines go through the point 0, 0. So that's not even true. It's not even true, right? So it's got to be choice D. This line and this line intersect each other. This line intersects this line. That's true. They intersect each other right here. That's why they have one system of equations. Okay. So it's confusing the way it's worded, but if you think about it, you think about what they're all saying, hopefully you'll understand what the answer is. All right, you guys, I think that's it. Yes, that's it. So I hope that helped you. And Tuesday, you're just watching this video and you're taking notes and you're doing these problems along with me. And then Wednesday, you're doing the substitution lesson. And then on Thursday, you're doing your mid-module check. And Friday is a makeup day. No zeros, everybody. No zeros. All right, you guys have a great day, a wonderful week, and I will chat with you all later.